Hey, this is Jody with weldingtipsandtricks.com. This week's project is an aluminum fixture. Parts range from 1 inch thick down to 3/8 of an inch thick, so I need some juice to do that. So I'm using a new machine here, a Lincoln Power MIG 350 MP. It's a multi-process machine that'll do TIG, lift arc, MIG, and stick. And today I'm going to be using a push-pull MIG setup and welding this aluminum fixture together. Now the base plates for this thing are 1/2 inch thick. I wish they were a little bit thicker, because they tended to want to warp a little bit, and you'll see later in the video some steps I had to take to prevent that. But I'm just laying it all out here to begin with and kind of getting an idea how it's going to look before I put the first tack on it. You can see this is just gravy work. It's nice clean aluminum, and the machinist has even indexed little 10 thousandths deep scribes for where everything goes, so it's just like putting together a puzzle. But I've got a little tight spot here. A little bit tight getting the gun down in there, and those 3 lugs there where a hydraulic cylinder attaches. The print calls for the weld to wrap around those corners and weld it up in there a good ways, so it's going to be tough to get that MIG gun up in there, so I'm going to have to weld the lugs on first. And so I'd rather weld that post on first, but we'll see how it goes. So now that I got an idea of how things are going to go, I'm going to get the first tack on it. I've got a 1 inch pin lining up all 3 lugs to make sure I get things going in the right direction. We'll get a tack on it and then hold it down and get a second tack on it. And that middle piece is 3/4 inch thick, and the outside pieces are 1 inch. So I'll remove the pin, and the first thing to do is I'm going to weld the ends of that 3/4 piece to prevent it from drawing one way or another very much. So I'll weld this one right to left, and I'll turn it around and I'll go the other direction on the other end. And once those ends are welded, it's not gonna draw much from side to side when I weld each side. But the plate itself is going to want to buck. I know that. I just know that going in, so I'm going to clamp it down here and try to prevent as much of that as I possibly can. Get it kind of locked down. As much as possible anyway. There's some amount of warpage that's just kind of unavoidable. But we'll take some steps along the way here, and you'll see when we get there. Alright, so we'll weld one side of this thing and then the other, and then we'll put the pin back in, line everything up, and then tack all the other 3 lugs up, and we'll just get her done. Now I didn't have time to really play with this machine a whole lot and find a real sweet spot. I just had to get this job done. I was kind of behind the curve a little bit, and that'll come in future videos. We'll talk about pulse on pulse and different pulse settings, and straight spray versus pulse spray, and all the different settings this machine has, because there's a lot of them. But for this video, I'm just getting this fixture done, and then we'll come back and we'll talk about all those settings, and we'll do a little TIG and stick with it in a future series. So getting all this stuff clamped together, you see I'm using some little spacer pieces of round stock along with a longer piece to line everything up. That's how they're supposed to be. Just so happens the round stock provides just the right amount of space. And we'll get a few tacks on this thing, making sure that pin is staying loose the whole way, that doesn't bind up. So we're good there. Now I always want to weld the ends, like I did on that first one. I want to weld the ends first. That way they'll draw a whole lot less when I weld the sides. And actually didn't have any trouble at all with these withdrawing, because the pin slipped in and out very easily after I was done. I see the gun angle here. You want to always keep a push angle when you're MIG welding aluminum. That allows that cleaning action to work the best and prevents soot, or prevents most of the soot anyway. You're always going to get a little bit here and there unless you've got just perfectly pristine conditions. But just a little surface soot is just kind of a symptom. It's not necessarily a defect. Just means that things aren't quite optimum. Your gun angle is not quite optimum, or your shielding gas is not perfect, or something like that. But it brushes off. It's not the end of the world. Now, what I'm doing here is I can see this thing starting to warp a little bit, so I want to get ahead of the curve. And I've got 2 of these to make, so I'm going ahead and tacking the base plates together. And what I'm going to do is I'm going to weld all of them up with the base plates tacked together so that they'll be pulling against themselves. And that's really a good practice if you're doing any kind of post with a floor, flange plate on it or something. If you're doing 2 of them, tacking them up where they pull against themselves is a real good way to prevent warpage. And so everywhere I put a weld on here, there's going to be an opposing weld on the other side. Now you can see I've got quite a few tacks tacking those round base plates up together. I'm going to wind up with a lot more than that because I heard a couple of them pop as I was welding the things out, and I had to come back and put more. And we'll talk about that a little bit more as we get farther in the video. Now you see, they didn't give me a whole lot of space in here to weld. Now that's a little bit of a problem. I can get to it on that middle one. It winds up putting me quite a long stick out, but coming through it from different directions to the middle, I can actually get to it. Now, I welded a bumper up some time ago from swagoffroad.com, and they had some similar lugs there, and they were made like this, where they had a little lip on them that was cut and with a little slot that indexed themselves, as well as just plug welded from the reverse side. I don't know why. It seems like that would have been a great way to do this. Just plug weld them from the reverse side. Would have been a whole lot less warpage and everything, but that's not what the drawing said. So I'm kind of stuck with what the drawing says, or I gotta, contact the customer and get approval to deviate from the drawing, etc., etc., and then that's a problem. So I just sometimes it's just better to roll with it. But it didn't seem like to me like the smartest design here. It would have been better to have that lug on there and stick through and then plug weld it from the reverse side. So we'll get that upright post welded in. Speed that up a little bit here. And then the next thing is these gussets. And they're supposed to be welded, both sides, top and bottom. And that's a lot more heat that's going to contribute to the warping of that base plate if I'm not careful. Now I'm using the pulse setting on this thing, and one good thing about the GMAW pulse is that it does help welding out of position. Like if you're going vertical up, it definitely helps in controlling the heat and having the thing not sag and droop and everything with you. It's very easy to control a puddle going uphill using the pulse settings. And this thing is synergic too, so you don't have to get into setting pulse settings real deep. You just set the pulse on. It's a pre-programmed program number you pull up, and it's synergic, so all you do is set the wire feed speed and it sets the voltage for you. And so it's pretty nice. Now you can see, instead of a spool gun here, I've got a push-pull gun. That's a lot nicer than a spool gun as well, especially in the angle I'm holding it right here. I'd be a little bit more uncomfortable with a spool gun. So this is just a little bit bigger than a normal MIG gun. Very nice. Pretty much a Cadillac. Again, I'm motoring on here with a little bit of a push angle. You can see that cleaning action there, breaking up the aluminum oxide ahead. And the whole thing is getting rather warm here right now, as you can see. So I've got a TIG finger on my pinky, kind of as a heat barrier for me, so I can hang in there a while and make the whole run. I tweaked it and I adjusted it and messed with different wire feed speed settings and everything, and so finally I'm getting something that looks halfway decent. Unfortunately, I'm almost done with the job by that time. And after I'm done welding all this stuff, I'm going to heat this thing up, and it's going to take a while. I'm only going to show a couple of seconds here on the video, but it actually took probably close to 10 minutes of using this rosebud on here to get it up to a temperature where it will actually be, somewhat of a stress relief, where it will allow it to relax and not just pop when when those tacks are ground off, which is around 350 degrees Fahrenheit. Now you can see the tacks are way bigger now on this side. I did have to beef them up. I started hearing a tack pop here and there as I was welding this thing out, so I built them up, and I used a cold setting, and I just built them up high so that I can grind them all off easily, so they didn't penetrate very deeply. And so with a grinder, I just ground them all off to where they were pretty much flush. And just the fact that they didn't pop when they were flush tells me that it did relax and there wasn't much stress left on it. So just popped it loose with a chipping hammer there, and I'll clean up the little burrs with a grinder and a flap disc. And when I set them on the floor, they were nice and flat. So mission accomplished. So this is part 1. Stay tuned for part 2 using that Lincoln Power MIG. These fixtures have a top half that's got a bunch of wheels and different gussets and all kinds of stuff, and we'll bolt the hydraulic cylinder on and all that stuff. So part 2 should be interesting, and part 2 hopefully we'll go over some more of the settings and capabilities of the machine. Thanks for watching.